Without mathematics, there is nothing you can do. Everything around you is a number. Everything around you is mathematics. Mathematics is omnipresent. It is embedded into our lives so deeply that we cannot live without the presence of mathematics in our everyday life. May it be in currency exchange, size of our clothes, or even the amount of data we use every day. Thanks to technology, which has brought us all together even during the global pandemic. We have seen mathematical and scientific technology grow to an astonishing extent. Today's webinar highlights the changing technology paradigms and the role of maths. Greetings of the day to one and all present here. Today, we learn about how technology is insufficient without the role of maths. But first, we invite our esteemed chief guest for the lamp lighting ceremony.
Today, we have invited Mr. Rahul Kumar Singh, who carries a rich and versatile 26 years of experience in managing software development of large and complex products in the telecom domain. Sir has definitely proved his merit, presently working as a Vice President and Engineering Group Head at Capgemini. Not only that, but Sir is also a BITS Pilani alumnus. It takes a big heart to help teach young minds. Our respected chief guest enjoys mentoring and teaching children as a hobby. It is an honor to have him here. Welcome, sir.
Thanks, and thanks to my dear children. Pretty excited to be part of BVN family today. My heartfelt thanks to Principal Ma'am, Mrs. Kushwaha, Maths Department, Disha Ma'am, for getting this all organized and enabling this, plus all the dear teachers and students who are present today for this talk and webinar. I must tell you one thing, right? The BVN name carries a huge respect and credibility in the market, right? And this speaks about the standards and the great work which all the teachers, students, and management of this school has accomplished. I think you are one of the luckiest to be part of this fraternity and family. So coming over to the topic today, right? I would say it's not a teaching class, or it's not about what we actually teach in class or in the curriculum and the subject, but it's more about what I have gathered and what I have seen during my 2.5 decades of experience being in technology, right? And how really things are changing and changing for the good. And if we will not be keeping pace with the changing technology, how we can soon become obsolete. Definitely, maths is going to have a huge role when it comes to computing, computational maths, computing science, and in a lot of technologies, maths is the core pillar, which enables a lot of things which we will see today in the webinar and presentation. Of course, I would like it to be highly interactive. My preference was always to have it face-to-face so that I can actually interact with all my children, students, and be very interactive and answer their queries thereon. But yes, due to this pandemic and the circumstances which we are having, we'll have to keep it virtual. Sorry and apologies about that. And another thing which I want to mention here is that See, these are my thoughts and my experience over these 2.5 decades. Of course, the topic is wide and very, I would say it has huge breadth. So apologies if I don't cover all the aspects of this topic because the time is limited. But what I also wanted was to give you some triggers and I would say some pointers so that your mind start ticking. And seeing the BVNites are, I would say, they are an intelligent lot, so they can take cues from here and really can imbibe some of these aspects in their day-to-day learning and how it can help each one of our students to have a great career ahead. Another thing I wanted to mention here was that though the role of maths is being talked about today, but we cannot undermine any other subject, right? So each and every subject which we study, it's part of the integrated learning which we have, right? And at any point of life, you would find it coming handy to you. But yes, today's topic is around technology and how maths enables the technology. But I, being myself a pure science student, I cannot undermine the benefits from physics, chemistry, social sciences, language, computing, software languages. All those things actually they pave our lives and they pave our careers, right? So that's what I wanted to just clarify because today the topic is more on maths. But yes, each and every subject is very important. And at the end of today's discussion, I would like to have questions and answers. And basically, I would like to dispel if there are queries, if I can answer those. And in any way, if I can help you to have a brilliant career ahead, right? So give me a sec. We will start with the presentation. And of course, I would like to keep it highly interesting. And that's why you won't find a lot of verbose slides, but and not of hard work for you, because I know it's a chilly morning and going to be a chilly afternoon. So you'd like to all relax. So I've tried to keep it very, very simple, and simplicity is the key, and how you can see technologies around you changing. And I've also tried to relate it to the concepts which the children in class 8, 9, 10 are learning. Okay, give me a moment. I'll just share my screen. Hope the screen is audible and sorry, the screen is viewable and I am audible. If there are any issues, please do text it on the chat window. So yes, the topic for the day is changing technology paradigms and role of maths. So what we are going to cover, of course, like to have some structure to this dialogue and to this talk, we will discuss technology trends, how different technology trends are collaborating, the connectivity revolution, the key data points, and how both of these together are having impact on our day-to-day lives. And then we will touch upon the most important part of it, that what you study currently, what is the role of that subject and role of those elements into these evolving technologies. I would also like to cover today innovation and startup mindset, because new education policy, and even if you see the India as society, we are making, I would say, huge inroads into this entrepreneurship and startup mindset, and how the startups are evolving. And so basically, I want you to encourage many of our students to learn about it and to think whether this should be the way forward for some of you. And definitely towards the summary, like towards the end, we will summarize that what's in it for you and how you really can modify or tweak your learning so that you have great careers, all of you. And that's what I feel from the bottom of my heart, that if my talk today can actually spark those elements into your mind, and if you can take up great careers ahead, I would be the happiest person, along with your teachers and the entire staff of BVN. So if you see very broadly, right, and these are some of the technology trends, and I will connect the dots here, right, because a lot of time we talk about various technology elements. We talk about things in isolation or silos, but we do not connect the dots, and that's what make people confusing, right? Uh, if you see the all these elements, most of these you used while doing SFH. And while my younger generation friends always try to bring out some acronym, this is my acronym. SFH stands for schooling for home, from home, and we all have experienced this during last 2 years heavily. If you see, there are 6 elements listed out here: internet and internet for all, wireless networks, internet of things, cloud infrastructure, data science, and artificial intelligence. A lot of, I would say, advancements and technological changes which are happening today, they are all interwoven around these 6 elements. And now I'll tell you how. Internet or internet for all definitely means that we have connectivity, or we have mechanism to connect two computers, two persons, end to end, and we can all do this better if we reach to each and every person on this earth, right? So internet for all is an, I would say, ambition where we can connect each and every individual, and we can provide better network connectivity to that. And you use this, right, while you are doing all these remote classes. Without internet, it would not be possible for any one of you to connect to the school network. And then we have wireless networks. Now, when we connect with each other, right, or when we connect, we always want 2 things, and very important aspect. One is the speed. We say that my network is slow, right? And a lot of times I've seen when I overhear some of the classes going on that I cannot connect from this place. I'm in a remote place, right? And my network is slow. My video is not getting shared, or my data is not getting scanned and uploaded properly in time during exams. And I have seen those frantic cries where people say that, okay, give me 5 more minutes. I have to scan it and I have to just upload or download it. But then this is highly connected to the competence or ability of the wireless network. And that's how you would have heard that 5G. We always getting all these Gs, right? 2G, 3G, 4G, 5G, and now people are talking about 6G. So what is all these? These are nothing but increasing speed and increasing bandwidth, that the amount of data which can actually flow through the pipe. So one is, we first, and I'll also revise it. First, we talked about the connectivity, that is internet. And then second, we are now talking about the quality of this connectivity, that is the speed and also the bandwidth. So each and every day, if you see and believe, we are using the number of devices using internet, or number of people or number of devices per people is increasing and increasing, right? So you need to have infinite connectivity in terms of speed and in terms of bandwidth. Then, so both of the first 2 concepts are highly connected, and we saw that as an infrastructure for our remote schooling or taking classes from home or doing online things. Then comes Internet of Things, right? So Internet of Things is nothing but where earlier when we started using internet, it was more about one computer talking to other, or one person using computer to communicate to other. But now if you see, Internet of Things is that all the devices around me, they are also getting smart. You would have heard of smart watches, you would have heard of smart cars. So, and now we are talking about smart locks, smart clocks, smart toothbrushes, smart dishwashers, smart refrigerators. So there's nothing but bringing the element of computing or having small chips inbuilt into each of these devices, so that they are also communicating with humans and they are also communicating with each other. Now you can understand, tomorrow there would be zillion or billion of people and devices trying to connect to each other. So you would require networks of very, very high speed, and you would require bandwidth in terabytes, or I would say where terabytes of data can be just streamed in seconds, right? So that's why people and scientists and engineers are researching always that what could be the faster mean to transmit or take this data all along. Now, we talked about the connectivity, we talked about the pipe, we talked about the everything getting connected. The another and very important aspect of, I would say, last 20 years has been the emergence of data. At one point in time when I was in school and when I was a kid, people used to talk that petrol is very precious, right? Petroleum is, and it's definitely a very precious resource, right? And then people talk about different things being precious, but today I can tell you, data is the most precious thing, right? Which all these technologies depend upon. So when you have terabytes of data, then the first question comes is that how do you store this data? It cannot be that, okay, I took the backup on my PC and then it just got crashed, right? So you cannot afford to lose any data. Like even today, I can tell you, like the children who are in class 10, they can go to their teams which were found in class 8 somewhere in the cloud and can fetch all the records, right? All their assignments, all their papers, everything. So when data comes into picture, then we need infinite storage, and we need infinite, again, bandwidth. And you should not be worried as a user where this is stored. And that's how the concept of cloud comes in. When I was a student and when I started my career, right, we used to have these IT rooms, right? Still a lot of organizations, schools have these IT rooms. But slowly, do you know, and these rooms were nothing but data centers where there were a host of computers, and we were trying to store data, trying to take backups. There were geo-redundancy sites where data in, say, Delhi is getting stored in Bangalore, because if tomorrow there is a crash in Delhi, you can take the entire backup from Bangalore, things like that. But now today with cloud, so cloud is nothing but array of data centers where there is huge computing processors and resources, and there is infinite memory, but you don't have to worry where the thing is stored. Look, for an example, when I started my career in 1996, which was 26 years ago, I had my mail ID, right? I have that mail ID even today. But for all these 21 years of mails, I have that in cloud, right? So I don't risk of losing any of those content, right, at any point of time, right? So that's how cloud comes in. And people take, what is cloud? So cloud is basically virtualization of the infrastructure which we have. So we are not worried. We just send it to cloud, upload to cloud, and take information from cloud. And then the fifth element brings is data science or analytics. Now, when you have so much of data, what you can do, you can analyze that data, and you can bring up a lot of interesting, I would say, correlations out of this data, which can be used by businesses, which can be used to study the trends, which can be used to monetize many things. So this is nothing but data science or data analytics. And then the final step is adding the cognitive computing or artificial intelligence or machine learning onto this entire data which we have collected. So basically, this is nothing but a paradigm to, I would say, come up with recommendations, come up with predictions, and come up with recommendation engines, so that you can actually try to mimic cognitive abilities of human brain, right? So if you see all these 6 things, I think it's very, very simple. You need connectivity, you need huge bandwidth, you need higher speeds, you want every device to be connected to each other, right? So internet, wireless network giving me the speed, Internet of Things giving the connectivity, cloud infrastructure giving me huge data and huge memory, huge computing power, and then I am actually trying to make my applications or analyze this data and then apply artificial intelligence. So if you see, lot of the concepts technically, and what I'm talking about is not at all for one field. Every field of science today, whether it is scientists who are working on vaccines, on genome, medical scientists, aerospace scientists, everyone is using one or the other of these elements, right? So hope I have been very clear here, and I have been trying to explain it very, very simply. Of course, all these concepts are highly complicated, but seeing the children from class 8, 9, 10th, I want to make it very simple for them. And we will also take questions and answers. So finally, advancements in computing power and ecosystem support is the summary from this slide. Now, for a minute, we should also remember that we called Internet for all. What does it mean, right? So all this is useless if Internet and this all advancement is not reaching to entire population on the globe, right? Now, let's look at some of these data points, right? In 2020, Jan of 2020, we had 7.75 billion people on Earth with an urbanization of 55%, which means 55% live in cities and metros, or they are non-rural areas. Then unique mobile phone users were about 5.19 billion, which is 67% of the entire human population. And out of which internet users were 4.454 billion, which is about 59%. 59% penetration, and active social media users are 3.8 billion, which is about 49%. Now, if you see, of course, in last 2 years, this would have increased many folds again. And why so? Because COVID-19 actually accelerated this further, right? So 2020 figures and 2022 figures, definitely some of my friends may come back that, Rahul, this is totally zoomed past ahead. Yes, I would agree. And that's what the benefit arising out of this pandemic. So if you see, in 1995, when I started my career as a software engineer, we have only an internet penetration of 1%. And it is risen by 60%, 59% in 2020, that's 25 years. And global mobile phone users penetration, which was also 1.6%, is now 67%. Now, when I come back again to this concept of internet for all, so the effort should be, and that's how, if you see, a lot of these organizations are working that for their products to be available, for their services to be available, they want everyone to use internet. So maybe not even the urban people, entire rural population should also be able to use internet. And then only the power coming from all these 6 concepts can truly be realized. So I think I've been very, very simple. And now some very, very interesting facts here, like, and we'll see how this has all changed or impacted our life. When I was your age, or when I was in 1990s and 1980s, my mail used to look like these letters, Indian letters, postcards. And today the mail look like this symbol, right? It's on a computing device. It's in your notepad. It's on your laptop. It's on your mobile phone. And then photos. When we used to click a photo, there was a huge dressing and there was a huge preparation being done. And these were the cameras then. And now you see the power of cameras, right? So you cannot even differentiate whether your phone is a camera or it's a scanner or it's a talking device or it's a data processing engine. So everything is getting converged, right? And my shopping was always offline. We used to have a shopping day when we used to go with our parents, but today it is on the click of the button. You all know how you are shopping. So you see the shift or impact of technology in this last 25 years, right? And if you move forward, when you needed a number of anyone in the neighbor or anyone in the society, you had these yellow pages or directories, and now it's search engine or any other directory which is present online. If it was the matrimonial, then you used to have all this detailed Kundli matching and horoscope matching, and now you are having online matrimony. And when you wanted to talk to your friends, I don't know whether a lot of you have seen this instrument or not. I think most of you, at least till class 10th, would not have been born by that point of time. But of course, these were the instruments, these were the initial telephones which we used. And today, I think there are a lot of mechanisms to be closer to your friends in social media, right? So this is how, if you see, your day-to-day life has been just changed by all these aspects of technology. And all those 6 aspects which I have told, each one of them, somewhere or the other, they actually play a huge role in this transformation. Now, switching to another very important aspect is, we have several industries and people make careers in industries like automotive, advertisement, news, entertainment, right? Now, if you see all these technology, what it has done, and it is very, very thought-provoking to actually sit down and understand what is really happening. Even the players who were making automobiles, they are getting transformed into technology players. Now, companies and organizations are coming who were technology companies or organizations, but now coming with connected cars, driverless cars, right? So it's not only the traditional automotive makers who are making automobiles, but it is getting extended. So basically the industry lines are getting blurred and merged. Advertising. Initially, we had set of organizations or companies who were doing only advertising. But now if you see all the technology companies, all the search engine, their monetizing model or the way they get businesses by advertisements, right? Everywhere, even if you open an app in your mobile, there would be some 5 seconds of ad getting played. If you are watching a streaming movie on a streaming platform, there also the ad would come, right? So how does advertisement industry has really changed, right? Or the print media again, right? So it was totally offline and totally paper-based, right? And now if you see entire print media or this is becoming online, right? So much so that in US, right, lot of the places, they are not now having offline papers, newspapers like we are having in our places, which is being delivered by the hawkers every morning. That is completely finished and stopped. So, and even for the books, right? The books manufacturers who were having huge business, they all are now digitizing and they all are now moving to ebooks, right? Similarly, for entertainment, the organizations or industry which were predominantly made for releasing the motion pictures or releasing things, they are not really, now you would see players also coming from technology world, because the technology which I talked about, the cloud, the data analytics, the AI ML, it is a totally different landscape. So they have entirely changed the way the business is run, the way the business is being done. And I'll try to give you a data point here. When I was started as a young engineer, the top 20 organizations in the world, and if I take those top 20 and I compare the top 20s today, only one name is constant in that list. Rest all have changed. That means the organizations which kept up with this changing technology find their place, or there are newer people who have just come up in that list, but people who didn't change, they were not there in the top 20 list, right? So this is how the industry lines and things are getting meshed up, interwoven, blurred with these technologies. We'll just take an example here. I already talked about it, that on the left side are the, I would say, the great automotive players, and on the right side are the technology companies. Now, today, if you view, you would say that a lot of these organizations, whether they're technology or automotive, they are all making automobiles. And they are and why this changes? Because every device is becoming smart and connected. Okay. So I think at this point, we can, I would say, a logical break means one of the portion of the discussion or webinar is done, which really means that how these 6 concepts are striking or are actually changing our lives day to day, how it is changing the business paradigm, and how it is changing the technology paradigm. I'll again at this point come back to my original slide. So again, maybe just a refresher: internet and internet for all, powerful wireless networks, which can give you speed and content at lightning speed, connectivity and smart devices talking to each other, then terabytes of data getting stored and processed very quickly, and you even don't know, and no one can even fathom if we can lose any bit of our data or any information, right? And data analytics, that is processing over the top of this data and bringing out some very useful correlations and concepts, and then maybe adding the cognitive computing element. So all these 6 things basically have changed our lives significantly. Now, let's take a way forward, and now we touch upon the topic of role of maths as basic enabler, right? So definitely maths teaches us to be very, very objective, very, very analytical. It actually ignites our analytical thinking and abilities, and in our brain also the analytical part of the brain is getting ignited. It teaches us the usage of algorithms, and I may tell you, algorithms are a fundamental part of computing science and computer science, right? We would be having people here in class 8, 9th, and 10th, and some of them would definitely want to become the ace computer engineers of tomorrow. So I may tell them that algorithms are a key and fundamental part of any computing science curriculum around the world. The best of the universities and the best of the best teaches and that's how the best computer scientists are those who come up with most efficient and most I would say modular extensible algorithms. And definitely people ask that what we are getting taught in classes 8, 9, 10, how is it really related to what we do in, say, computing science, cognitive sciences, deep neural networks, their analysis of networks. So if you see, of course, every element of the subject is very important, but some of the very, very important element of maths which are being used is binary maths. Of course, you guys are right now getting taught the decimal number system, but then when the base of the number system changes, then we can have a binary maths where hexadecimal numbers of having base 2 are being taught. Then it actually gives rise to the logic theory, and logic theory is nothing but on which a lot of the computing circuits and computers are based on. The machine language finally which a computer understands, it's in ones and zeros, right? Where we also call it every computer or every chip in the processor would have its own machine language. And when I was a young engineer, we used to also code in machine language format. Today we have languages like Java, C, C++, Python, but those were the very primitive times. Then we have algebra, right? So equations, linear equations with different powers and huge number of coefficients are highly used, I would say, in algorithms, and also in many parts of computer science. Then third is statistics, and why it is important, and it's one of the base which is being taught for a person who aspires to have a career in artificial intelligence and machine learning, because statistics tells you a very important concept of correlation and regression, right? How you can actually extrapolate a trend which you are seeing in a graph. And if you combine both algebra and statistics, then there would be concepts like curve fitting, which some of you would have studied already, like linear programming, right? Where you have certain constraints and where you have two equations, and then you plot a graph, area of the graph, which is the most suitable as a solution to it. Then definitely calculus, which is rate of change calculation, whether it is differential calculus or integral calculus, that is very important. And then definitely discrete maths. So these are some of the very, I would say, salient elements of a maths curriculum. Of course, you would start reading, you are reading them in 6th, 7th, 8th, 9th, 10th at different levels, but each of them is very important if tomorrow some of you want to aspire to be great engineers, right? And using computer science and electronics and I would say data analytics, AI, ML. So all this thing is very important. And then if you see, if we go further down into it, some of the salient things which are used by these technologies, which I just talked about, AI, ML, and deep neural networks, as I mentioned, is statistical correlation and regression. So people who are studying mean, median, mode right now, and then they would also study correlation and regression. They would also study probability. So all these things are highly important. Then I also talked about linear programming, linear equations. Then we have curve fitting, algebraic equations of various degrees and various, and there are, I may tell you, when we do deep neural networks, there are equations, there are hundreds of coefficients and number of variables, and where they actually train the networks again, or the neural networks based on these equations by deriving the feedback loop and then actually giving those inputs. And finally and foremost is the graph theory, right? You started using some of the Euler's formula, but when you come to a rich graph theory, that is highly used in algorithms, right? Now, when you come to internet or search engines and data science, right, there again, the search algorithms, right, would be highly important. Now, very basic example of a search algorithm could be, say, I give you 100 random numbers. Now, how quickly you can arrange them in an ascending or descending order, right? That is very important, right? So these are and we call it order of execution. Order of execution means how quickly you can actually calculate a thing. And we talk about that this algorithm has a power, can calculate in, if there are n variables, this will calculate in n log n time, and this will calculate in log n time, this will calculate in n square time. So that's how we rate the algorithms. And then using these algorithms, we come with recommendation engines, and we find the fastest routes. One of the example is the Google Maps, right? We always are stuck in traffic, then we, using the help of GPS, mobile, and these algorithms, our best route is recommended for each one of you, right? Two other concepts, and very important one, are the cryptography or cryptocurrency, which we all know. And the best, I would say the best of the best cryptographers use ciphering and encoding, decoding. Some of the encoding, decoding in a logic theory you have understood, but later on you would actually learn how different encoders, decoders are made. Because even when you speak on the mobile phone, the entire voice content which is going from yours to the another mobile, it is completely encrypted. It cannot be, if you take that piece and you try to extract voice, you will need a key which was needed to encode, and there should be a reverse key to decode the message. Then in aerosciences, we use mathematical modeling, simulation of electrical and mechanical design, any aerospace thing, whether it's aircraft, fighter jet. Thousands of hours are actually given to simulate the flight first, even before the flight takes off. So that's the power of maths in the changing technology. And if I just give one other view, so this is the cognitive computing on AI ML. So you have data, you have application, and then you have algorithms. And if you see the last part, algorithms are all powered by mathematical concepts. And some of the languages which computer science teachers are teaching nowadays, the R language, Python, they are heavily used when we actually predict AI ML, we come up with AI ML models. Along with all this maths, two more important things have really revolutionized this thing. See, the hardware technology is getting better and better every day. If you see what I could have taken as a computing power in a very large machine 30 years back, that computing power now comes in a small mobile phone. So chip sizes are getting decreased, their battery requirement are getting decreased, and processing capability is getting increased exponentially. And if you see the clock frequency for 25 megahertz in 1990 of a processor to 4 gigahertz in 2015, now we talk about quad core, hexa core. So all these is how do you make the processing or the processor faster? And similar advancements, I already talked about the storage devices such as RAM, hard disk, and now we talk about the cloud. So for devices to connect with each other, we need each device to have very smaller chip, very lightweight battery, and a very long battery life. In software technology trends, if you see, first, when I was an engineer, we used to write in machine coding languages. Now people move to C, and all these is a highest level of abstraction being given. Now people are using C++, Java. For the front-end side or developing the user interface, we use Angular, React, and React.js. And more importantly, for AI ML, we use R language, which is nothing but a lot of statistical concepts come there. So both these trends also have empowered the technology shift, which I talked about. Finally, I think we are just completing the time. So I'll first come up with what's in for you, right? So now, why I talked about entire thing today was because if you see 25 to 30 years back, the jobs which never existed are the jobs of today. And 2016 World Economic Forum Future of Jobs report says that 65% of children in primary school and children like you would actually end up doing jobs which don't even exist today. So I even don't know what type of job can come out. Because you just take an example, the things which were all done manually yesterday, even when you wanted to talk to a customer service representative, now what comes on any website is your assistant, right? Hey, I can help you. So that's nothing but remote process automation. Now, due to that, if you can understand how many job profiles would have changed. So my only message to you, dear students, is be open to change, be curious, learning how to learn and transform at your level, and then only you can get the jobs of the future, or maybe some of you can actually create jobs of the future. As a student, these are the golden things. I have always, during my career, I have always been highly focused on these. And so I would definitely, the times are changing, so are the different things are coming, but technically fundamentals should always be very strong. And how you interconnect the dots, like we did today in the presentation on the 6 elements and how it helps your life, that is highly important. You have to be always inquisitive and curious to learn new things. Be always analytical and objective in your reasoning. Don't get judgmental or subjective. And we say, like, we trust in God and we trust in data, right? So whatever data says, we actually look at it objectively. and then we make decisions out of it. Focus on excellence. Whatever you do, right? Whichever stream you take, do become one of the best in that stream. Soft skills, definitely. Be always humble, grounded. Attitude matters a lot in all the careers. Be a team player. Energy level and initiative taking has to be superlative. And of course, icing on the cake is good communication and listening skills. That's basically polishing. And like, I would just say that tie in 8th to 12th standard as a purpose-led story, which means that sooner you decide what you want to do, then actually come up with the entire plan, which will lead towards your goal. And take real life projects when you do assignments and anything. Take how technology is touching human beings and how it can really help you. And learning a language versus professional quality coding. So a lot of people who want to take up maths, computer science, see, coding is an art. Always try to code. The better you would code, the better computer science graduate you would become. And it's always an art. I'm telling you, you can write a code too. There can be two pieces of code, both can do the functionality, but then one could be highly modular, which does that problem solving in much lesser time, is extensible. That means that it can always be improvised without even changing the architecture. So that is an art. So people who are interested in, or students, my children who are students towards interested towards it, they should basically do a lot of practice on coding. And finally, right, when was the last time you did something for the first time, right? That's very, very important. And if you really remember this, then you can really reach to the top and you can have great careers ahead. Thank you.
Thank you, sir. All the students to note, the attendance link has been provided in the live chat option for students. Kindly fill. Please forward your queries to your maths teachers, which will be answered by sir.
Thank you, Suhana. Thank you so much, sir, for such a wonderful presentation. It was really enriching and informative. When we told the students that we would be conducting a workshop on such an interesting topic, they all were very excited to ask questions. But due to the scarcity of time, we were only able to take up a few questions. Firstly, how can we, as students, contribute to the changing technology through math?
Okay, so I think through maths, I would say first and foremost is study maths, and study maths from an angle where you understand the concepts and join the dots, as I told you, right? And then basically when you are practicing maths or when you are applying maths in your programming or when you do computers, then try to apply the concepts and make your own programs, make your own problems. You can just take any book and try to solve problems using your computer software programming or the language which you are doing. So basically what it will do is, whatever concepts you are learning, you are also applying to a wider problem statement. So if you will practice like this, tomorrow, if you have an idea for something or some product, you can very well actually try to simulate it on your computer itself, right? So while you learn intelligently and learn keeping in mind the overall concept and try to code that problem statement of maths using any of the software language.
Thank you, sir. Another question, sir. Is maths essential if I wish to make my career in the IT sector?
Yeah, so this is a very good question. And in fact, yes, maths is an essential topic when it comes to IT sector. But let me tell you, there are two elements in IT sector. One is, if you really want to be a core computer engineer, definitely without maths and without learning some of the concepts which I talked about, like algorithms and data science, maths is mandatory. But yes, even people who want to be computing users, right? They can have a career in IT sectors where I believe, of course, not today, but in future years or in coming years, there could be some relaxation where even people who have studied elementary maths can become very good, I would say, computing users, right? Today, of course, we have courses like BCA and MCA as well, where so BCA, MCA teaches you most about how to be a good computing user, vis-a-vis courses like computer engineering or electronics and IT engineering, which talks fundamentals and which more focuses on the algorithms and how to do it part.
Thank you, sir. Moving forward, what education should I pursue after 12th to make my career in the computer technology sector?
Yeah, definitely. Best education, if I would say, still say, would be a degree in computer science, electronics, or doing a great MCA. That would definitely be there. But let me tell you how things are changed, right? Now we have super specializations or fields in data analytics, data science, which was not there earlier, right? That's a new branch which is evolving. Then we have a branch in artificial intelligence and machine learning, right, which is also getting evolved. Then there are a couple of, I would say, integrated disciplines like biomedical engineering, right? This all science of genetic sequencing, genome, vaccine, when these scientists are doing all the vaccine discovery, etc. This is highly used. So if you need to know, I would say there are 6-7 more super specializations in the computing science field itself, which have now emerged, and that gives a lot of choices to our students, because someone as a domain can be very much interested in, say, biomedical engineering type of a thing, because he also loves biology, but he also loves maths. But yes, then this is the field to go. So all those things which were not there 25 years ago, we are seeing a lot of new integrated disciplines.
Thank you so much, sir, for your valuable inputs. I would now like to pass on to Suhana for the vote of thanks.
So, we wish to express our sincere gratitude towards you for enriching us with the knowledge of the current digital landscape. In fact, the valuable inputs that you shared about how mathematics is a key component in technology were quite interesting. We thank all our teachers and students for making this webinar a success.
So thank you again, and thank you everyone for giving me this opportunity to speak about this. Thanks to the entire BVN fraternity.